Today we're going to do the first part of our lesson on writing linear equations. And today we're going to express the relationship between two quantities as a linear equation. And then in our following lesson, we will use the table or graph to represent a linear equation. So that will be the part 2 of the lesson coming up next. So our two standards are below. 6EE7 is our first standard that we'll be addressing today. And then 6EE9, pretty lengthy one here, will be our second standard that is addressed in these lessons. So here we have our first situation. Caleb is X years old. His sister is 10 years older than he is. If his sister is Y years old, write an equation that relates their two ages. Well, many times when we're given a word problem and we have to create a linear equation from that, we will see something similar to a statement of Y in terms of X. And when we see a statement like that, it tells us how the equation should look. And so if we want the equation to be Y in terms of X, we will actually start our equation with Y equals. So to finish the equation, we know that Y is going to be based off of our variable of X, because Caleb is X years old. And since Y represents his sister's age, says that his sister is 10 years older than he is, so our equation would be Y equals X plus 10, because to get his sister's age, you must add 10 years to Caleb's. So X in this situation would be our independent variable. And it's our independent variable because we can make X whatever we want. If we want Caleb to be 2 years old, he's going to be 2 years old. If we want Caleb to be 20, he will be 20 years old. Which makes Y our dependent variable because it relies on Caleb's age. His sister's age is dependent upon his age. So here it just kind of reiterates a few things that we just went over. So in the equation, X is called the independent variable, Y is called the dependent variable because the value of Y depends on the value of X. And then writing Y as an expression using X is called expressing Y in terms of X. So our next situation here, a rhombus has sides of length r centimeters. If the perimeter of the rhombus is p centimeters, express p in terms of r. So here we have that statement. And since it says p in terms of r, our equation will start as p equals. Now a rhombus is special because a rhombus has 4 congruent sides. And to find perimeter, you add the side lengths. So you would take the side length and you would add it to itself 4 times. So we can just go to 4 times r for our perimeter. So in this case, we can make the side lengths whatever we want. So r is our independent variable, which makes p our dependent variable because the perimeter relies on the side lengths. So Isaiah has 8 baseball cards. Miguel has 7 more baseball cards than Isaiah. So for part A, we want an expression for the number of baseball cards that Miguel has in terms of H. Well, if Miguel has 7 more baseball cards than Isaiah, and Isaiah has H baseball cards, the expression would be H plus 7. If Miguel has K baseball cards, express K in terms of H. So that would mean it's K equals H plus 7. And the independent variable is H. The dependent variable is K. Hannah took P minutes to jog around the park. Sophia took 12 minutes longer to jog around the park. If Sophia took T minutes to jog around the park, express T in terms of P. So since we want T in terms of P, our equation will start with T equals. And if Hannah took P minutes to jog around the park and Sophia took 12 minutes longer, we're going to add 12 to Hannah's time. So our equation would be T equals P plus 12, which makes P our independent variable and T our dependent variable. We'll scroll up a little bit so we can do number 3 here. A bouquet of roses costs $30. A bouquet of tulips costs M dollars less. If the cost of one bouquet of tulips is N dollars, express N in terms of M. So since it says N in terms of, we'll start it with N equals. And if the roses are $30 and the tulips are M dollars less, we need to take however much less they are off of the $30. So N equals 30 minus M. And in this equation, M is our independent variable, N is our dependent variable. Nathan has 7 boxes of marbles. Each box contains B marbles. If he has C marbles altogether, express C in terms of B. So C in terms of B means it would be C equals. If he has 7 boxes and each box contains B marbles, we would multiply those together. So C equals 7B. B is our independent variable. C is our dependent variable. And number 5, a motel charges Mr. Kim X dollars for a stay. Mr. Kim stayed at the motel for 12 nights. If the rate per night for a room is Y dollars, express Y in terms of X. So Y in terms of X means it's Y equals. And if they charge him X dollars for his stay, that's the entire time he was there. So to find out how much it was per night, Y equals X divided by 12. And for this one, X is our independent variable, and Y is our dependent variable. With our linear equations, we are eventually going to put those on a graph, but again, that'll be in our next lesson. But to help us create the graph, it is important to create what's known as a table of values. And you create the table of values after you create your equation. So we'll start with our equation, and then we'll create a table of values for our equation. So the length of a rectangular picture frame is 5 inches longer than its width. Write an equation to show how its width and length are related. Let W represent the width of the picture frame in inches. Let L represent the length of the picture frame in inches. Now our problem here does not have the statement one variable in terms of the other. So if it doesn't have that statement, you have to determine which one's your independent and which one is your dependent variable. Your independent variable would be the information that you have to know first. It's going to tell you what everything is based on. So if it's the length of a rectangular picture frame is 5 inches longer than its width, that tells me that we would have to know our width first. So that makes our width the independent variable and length, or L, our dependent variable. So our equation would be L equals W plus 5. And now that we have our equation, now we would create a table of values. And for our table of values, you will put your independent variable on top, your dependent variable on the bottom. And as I'll go into with our next lesson, you must have a minimum of 3 sections here. You want to have 3 points that you can create. And I'll explain why in the next lesson, go into greater detail. There will be certain occasions where you're told what values to use. In this case, we are not given any values to use, so we can use our own. So maybe we want the width to be 3 inches. Well, if the width is 3 inches, we put 3 in for W, we solve our equation, and we'd find our length is 8 because that's 5 inches more. Maybe we have a pretty wide picture frame and it's 12 inches wide. Well, its length would be 5 inches longer than that, so we would add 5 to 12 to get 17. Or maybe we have an extremely wide picture frame, maybe it's 2 feet long, so that's 24 inches. So our length would be 5 inches longer than that, so we would have a length of 29 inches. Each can of paint contains 5 gallons of paint. Write an equation to show the relationship between the number of cans and the volume of paint. Let V represent the volume of paint in gallons and C represent the number of cans of paint. So again, we would need to figure out what information do we need first. And if each can of paint contains 5 gallons, we would probably need to know how many cans of paint we bought first. So the C for cans would be our independent variable, which makes V our dependent variable. And for each can, we have 5 gallons of paint, so our volume would equal 5 times C, 5 times the number of cans. We make our table of values. Our independent variable is C, so that goes on top. Dependent is V, so that goes on the bottom. And again, we need a minimum of 3 sections. We're not given any values for C, so we can use our own. If you buy 4 cans of paint, you put 4 in for C, 4 times 5, that's 20 gallons of paint. If you buy 7 cans of paint, 7 times 5 is 35 gallons. If you buy 11 cans of paint, 11 times 5 is 55. So for 6 here, we do have to write our equation, and then we have to fill in the missing pieces of our table. So the width of a rectangular tank is 2 meters less than its length. If the length is P meters and the width is Q meters, write an equation relating P and Q. Well, in this case, we would have to know our length first because it says the width is 2 meters less than its length. So Q would equal P minus 2. Excuse me. And so if we fill in the remaining pieces of our table, if P is 4, 4 minus 2 is 2. If P is 5, 5 minus 2 is 3. 6 is done for us. If P is 7, Q would be 5. And if P is 8, Q is 6. And since it's a linear equation, you should notice a pattern. Paul and Lee went to the library to borrow some books. Paul borrowed 6 more books than Lee. So for our equation, Y would equal the number of books Lee borrowed, X plus 6, because he borrowed 6 more books than Lee. So 1 is done for us. If X is 2, Y is 8. 3 is done for us. If X is 4, Y is 10. And if X is 5, Y is 11. And our final example today, at craft store, Zoe bought some boxes of red beads and some boxes of blue beads. The number of boxes of red beads was 4 times the number of boxes of blue beads. So since red beads are based on blue beads, red beads equals 4 times the number of blue beads. So 2 is done for us. If B is 3, 3 times 4 is 12. If B is 4, 4 times 4 is 16. If B is 5, 5 times 4 is 20. And that's it for today's lesson. As always, I hope this helps.